Have you ever lain down on a sunny afternoon, looked up, and asked yourself, why is the sky blue? It seems like a simple question, yet it took humanity hundreds of years to answer. In reality, that blue is not the sky's true color, but the result of billions of invisible collisions between sunlight and gas molecules in the air, a symphony between physics and light playing out right above us every single day. And if not for that phenomenon, Earth's sky would be pitch black, just like the moon's. From ancient times, the Egyptians believed the sky's blue was due to divine water covering the world. The Greeks thought it was the color of the colossal dome erected by the god Zeus to protect humankind. However, it was not until the 19th century that humans began to touch upon the true answer. A British physicist named John William Strutt, Lord Rayleigh in the 1870s, posed a very different question. If sunlight is pure white, why does it turn the sky blue when it passes through the air? He was not just curious, he brought the sky itself into his laboratory, and from there discovered one of the most important physical phenomena in history, the effect of light scattering, which we now call Rayleigh scattering. The story of light and physics. Sunlight is not made of just one color. In fact, it is a mixture of countless different colors: red, orange, yellow, green, blue, indigo, violet, creating the white light we see. When that light travels through the atmosphere, it encounters trillions of gas molecules, primarily nitrogen and oxygen. These tiny molecules are only about 0.4 nanometers in size, so small that it would take 250,000 molecules lined up to equal the width of a human hair. And that is when an interesting phenomenon occurs. Light is scattered, meaning it is pushed in all directions upon collision with the gas molecules. But not every color of light is scattered equally. Colors with shorter wavelengths, like blue and violet, are scattered 10 times more strongly than red light. This causes blue light to spread throughout the sky, creating the cool blue hue we see every day. Lord Rayleigh described the phenomenon with a simple yet miraculous formula. The scattering intensity of light is inversely proportional to the fourth power of its wavelength. Or put simply, the bluer the light, the more easily it is bent and scattered. The truth behind the sunset's beauty: in reality, the sky is not truly pure blue. Violet light is scattered even more strongly than blue light, but the human eye is less sensitive to violet, and some violet light is absorbed by the ozone layer, which is why we primarily see blue. If you were to fly up to the high atmosphere, where the air thins out, the blue fades until it vanishes, and the sky turns deep black, just as astronauts see when looking from space. On the moon, where there is no atmosphere to scatter light, the sky is completely black, even though the sun shines brightly. The Rayleigh scattering phenomenon is also the reason for the brilliant sunset colors you see every day. When the sun is low, its light must travel through an atmosphere many times thicker, causing almost all the blue light to be scattered away. Only the red, orange, and yellow light, colors with longer wavelengths, manage to reach our eyes, painting the entire sky in a warm, fiery glow. A simple law of physics, yet it gives rise to some of the most poetic scenes in nature. The hidden meaning behind the blue. When we understand why the sky is blue, we realize a profound truth. Every beauty in this world is the result of seemingly invisible things. A ray of light, a gas molecule, a tiny collision, and the entire universe becomes brilliant. In human life too, sometimes the most ordinary things, like the sky every morning, conceal the miraculous laws of nature and of ourselves. No blue color exists permanently. It is only light being scattered, reflected, and transformed, much like the moments in life, beautiful only when we pause to behold them. Thanks to the Rayleigh effect, humans not only understand the color of the sky, but also apply it to countless fields, from analyzing the atmosphere of other planets to simulating light in 3D films, and even in environmental research and climate forecasting. Every time we look up at the sky, we are looking at a giant laboratory of nature operating nonstop. The next time you look up at the blue sky, remember, that color is not random. It is the result of billions of interactions between light and air, between the sun and the earth, a testament to absolute harmony in nature. And similarly, human life is a symphony of small collisions. Light only becomes beautiful when it is scattered. Humans only grow when they embrace collisions, when they dare to go through the dark patches to find their own light. The blue sky is not just a color, it is a reminder that even in the chaos of light and dust, nature still knows how to create the most beautiful things.